6.8 is a theorem called the rational root theorem. And this theorem is, we use it to find the possible rational solutions of a polynomial. So a rational solution are all of the x-intercepts that can be written as a fraction or a whole number, like your nice ones, not the ones that have like a square root left in them, not the ones that are imaginary. And this theorem basically narrows it down to say these are what could be your x-intercepts. We won't know exactly which ones. Sometimes we have a big long list, but it tells us which ones it could possibly be. And then we could use synthetic division to find out which ones actually are the x-intercepts. So you need two things which we list as P and Q. P is we have to list out all of the factors of the last term, specifically the constant or the last coefficient. And Q, we list out all the factors of the first term. So we're going to have like two numbers we're going to list out all the factors of. So like 8, factors of 8 are 1 and 8, 2 and 4. And so we will do that for two numbers. And then these possible rational x-intercepts are plus or minus P over Q. So we take every factor from the last term and divide it by every factor in the first term. So sometimes that makes a big long list if we have a lot of factors. And then once we have found these possible x-intercepts, so the ones that could be the x-intercepts, one way to test them out is through synthetic division. And remember, if your remainder is 0, that means that it is an x-intercept. So let's look here at number 1. So I'm going to list out all of the factors of 8. And I try to list them in order. And the big thing is you got to make sure you get them all. Don't leave any out. So we should have 1, 2, 4, and 8. And that is a minus a negative 8. But our answers are plus or minus anyway. So you don't just list out the positives. And then 4, the factors of 4. So we took our factors of our last term and our factors of our first term. 8 and 4. 1, 2, and 4. So all of our possible x-intercepts, I take all of these factors. So 1 divided by 1, 1 divided by 2, 1 divided by 4, and I do that for all of them. And they're all plus or minus. So what is 1 divided by 1? 1. Plus or minus 1 divided by 2 is 1/2. Plus or minus 1 over 4. And then we do 2. What's 2 divided by 1? 2. What's 2 divided by 2? 1, which I already have, so you don't have to list it again. And what's 2 divided by 4? 1/2, and I already have that. So you don't have to list them out. You don't need to duplicate them. Okay. Then we have plus or minus 4 over 1 is 4. What's 4 over 2? 2, and I already have that one. What's 4 over 4? 1, which I already have. And then 8 divided by 1 is 8. 8 divided by 2 is 4, which I have. And 8 divided by 4 is 2, which I have. So 1, 2, 3, 4, 5, 6. So there are 12 possible x-intercepts. 1 and -1 could be an x-intercept. 1/2 and -1/2. 1/4 and -1/4. 2 and -2. 4 and -4. 8 and -8. Those could be the x-intercepts. And if I said, okay, now find them using synthetic division, you could do synthetic division 12 times. But if I said, I want you to find them using synthetic division, be a little smart. And we could type in the function. We could see which ones actually are x-intercepts and just use those with synthetic division. So it looks like when we type it in, it looks like 0 is on there. Trace. Well, that's hard to see. I need to look that up because you might have to always include 0. I need to check on that. All right, number 2. We're going to list out the factors of 45 and 3. All right, number 2, factors of 45. We have 1 and 45, right? Not 2. What about 3? 3 and 15. Not 4. 5 and 9. 6, 7, 8. None of those go into 45. And then 3. Just 1 and 3. So what we have to do is take all of these factors divided by 1 and divided by 3. So we'll have, let's see, plus or minus 1. 1 divided by 1. And then 1 divided by 3 is 1/3. Plus or minus 3 over 1. And then 3 divided by 3 is 1, which we already have. Plus or minus 5. Plus or minus 5/3. 5 divided by 1 and 5 divided by 3. Plus or minus 9. What's 9 divided by 3? 3, which I already have. Plus or minus 15. And then 15 divided by 3 is 5, which I already have. And then 45 divided by 1. And then 45 divided by 3 is 15, which I already have. So these are the possible x-intercepts. That does not mean that they're all x-intercepts. This is a function to the 4th power. The most it could have is 4 x-intercepts. So of these 16 numbers, there's 8, but there's plus or minus. So 16 numbers, only 4 of them could potentially, and sometimes we don't even have all 4. Sometimes there's some imaginary ones in there. Okay. All right, number 3. We're going to do factors of 4 and 8. So 4 is 1, 2, and 4. And 8, 1, 2, 4, 8. So plus or minus 1, 1 over 1. Plus or minus 1/2, 1 over 2. Plus or minus 1/4. Plus or minus 1/8. Now we'll move on to 2. Plus or minus 2 over 1. What's 2 over 2? 1, which we have. What's 2 over 4? 1/2. And 2 over 8 is 1/4. So we've got all those already. And then 4 over 1 is 4. 4 over 2 is 2, which we have. 4 over 4 is 1, which we have. And 4 over 8 is 1/2, which we have. So there are 12 possible x-intercepts, rational x-intercepts. I want you to try number 4 on your own. All right, you should have plus or minus 1, 1/2, 2, 3, 3/2, 4, 6, and 12. You could have a different order if you kind of go about it a different way, but those are the ones that you should have. Any questions? All right, the biggest mistake that you're going to make is leaving out some factors. Don't forget 1 and 12. So a lot of people leave those out. A lot of people forget those.